Hello, welcome to the Newman Sixth Form Year 11 into 12 taster lesson for physical education, BTEC Sport Level 4. My name's Mr. Emmett, I'm going to be one of the teachers on the course. Let's start by just running through the outline of the whole BTEC Sport Level 3 course. We're interested on this diagram here. We are only interested in the extended certificate. This is the qualification that we're looking to achieve here. And that comes with 3 mandatory units. They are the anatomy and physiology, fitness training, programming for health, sport and well-being, and the professional development in the sports industry. We also then get a choice of 1 optional unit, which we're going to be covering the optional unit of Unit 7, Practical Sports Performance. I don't want you to worry too much on this diagram about the unit sizes. That's not really anything that you need to concern yourselves at just yet. So, today's lesson we're going to be looking at Unit 1, Anatomy and Physiology. When we look at Unit 1, it is broken down into 5 separate topics. Topic A, B, C, D and E. So within each unit, they're going to be broken down into separate topics. As you can see by reading this slide, you can see that we're looking at the effects of exercise and sports performance on the skeletal system, topic A, on the muscular system, topic B, respiratory system, C, the cardiovascular system, D, and then the effects of exercise and sports performance on the energy systems, topic E, which is the focus of today's lesson. So, like I said, our focus today is going to be Unit 1, Anatomy and Physiology, topic E. We're going to look at the effects of exercise and sports performance on the energy systems. So, we're going to be focusing today on the role of ATP in exercise. And we're going to be looking at one of the systems, the ATP-PC system, also known as the alactic system. We're going to be looking to understand this point here, understand the role of the ATP-PC system in the energy production for exercise and sports performance. We're also going to have an understanding of what ATP actually is. So those are our learning objectives today, as I've just gone through, to understand the role of ATP in exercise, topic E1, and then to understand the role of ATP-PC system in the energy production for exercise and sports performance. So let's get started. So the first thing we need to consider and we need to look at is what actually is ATP. So in the simplest form here, ATP is a chemical compound that provides energy to drive many processes in living cells. So for example, any muscle contractions, any jumping, moving, breathing, hair growth, anything like that, we're going to need a compound that's going to drive and give us energy to be able to perform that process. And that is where ATP comes in. So, as we look at our energy here, we can see that all movement requires energy. So everything that we do in our body and everything we do in our life is going to be required energy to help us perform that. Some of the activities require a large sum of energy in a short period of time. So if we think about a 100-meter runner, okay, they need a large amount of energy in a really short period of time to be able to allow them to perform and run at high speeds, while others are going to require continued energy at a slower rate. So if you think there of a long distance runner, So a long distance runner is going to need continued energy, but over a longer period of time. So all our energy systems that we have in our body work together, but the type of activity and intensity will determine which one is going to be more predominant, key word there, more predominant in that specific moment. All the energy that we have is obtained from a breakdown of the foods that are in our diet, so particularly things like carbohydrates and fats that have a high energy yield for our body to be able to take in. So we have three energy systems that we actually use in our body. So an intermediate, in the first instance, we'd use our ATP-PC system, which we're going to look at today. In the more shorter term, we'd look at our lactic acid, okay, our glycolysis or an anaerobic system. And in the longer term, we're going to look at using our aerobic system. Now, all three energy systems, like we said earlier, work at the same time. So it's not that one system will completely be providing all the energy that your body needs. It's just that one system might be more predominant in that specific moment, but it will be working alongside the other systems. But the three energy systems that we're looking at, we're only going to be focusing on one today, and that is the ATP-PC system. So let's look at our first learning objective then. So the role of ATP in exercise. So an ATP is a molecule that stores and releases a chemical energy for the use in our body, so in our cells and in our muscles. It has to be readily available to be broken down. We need ATP in that intermediate. That means in the first instance, we need that to be readily available for our body to break down and for us to be able to use. When ATP is broken down, it gives energy for the intermediate muscle contraction, so it allows us to start moving. So if you move your arm or your leg in this second, that will be your ATP system kicking in, and that will be providing you the energy. It is only the molecule that provides and supplies the energy used in the contraction of muscle fibers. Okay, so it's only the single molecule. It's not the whole compound, it's only the single molecule. So what does ATP stand for? So ATP stands for Adenosine Triphosphate. Adenosine Triphosphate. Hello. Welcome to the Newman Sixth Form Year 11 into 12 taster lesson for physical education, BTEC Sport Level 3. So if we look now at our PC part of the ATP-PC system, we're looking at the PC. That can be broken down the same way as the last ATP, the last phosphate was broken down on ATP. We can break down the PC system, and that helps us to refuel and resynthesize our ATP system, and I'll show you how that works. So PC stands for phosphocreatine, or as it's known, and it's a compound that has two molecules, it has your phosphate, and it has your creatine molecule. And again, it's got an energy bond that are linking the two. Now, like I said, this can be broken down that will refuel our ATP. And it's known as a coupled reaction. Let me write that here for you. Coupled reaction. And I'll explain what happens to that. So when we break down our ATP, when we break down that final phosphate molecule, we have something that's called an exothermic reaction. So an let me write that here for you. Exothermic reaction. So when we think of exothermic, it's a thermic reaction. Okay, it's thermic energy, but the exo means it's exiting. So this molecule is going away from the compound. Now, why do we call it a coupled reaction? Well, the PC system then kicks in, and with phosphocreatine we break it down into its two molecules, and again that would be an exothermic reaction. So we use this to fuel something called an endothermic reaction. Endothermic. And an endothermic reaction is going to be adding a phosphate molecule that we're missing. So we've broken down from adenosine triphosphate, we've taken away one phosphate molecule. Now that's an exothermic reaction. At the same time, a phosphocreatine molecule is being broken down, and that's creating another exothermic reaction. We can use this energy to add a phosphate back onto something called ADP, which is adenosine diphosphate. And we think dissection, splitting something into two, so having two parts. We can use that energy to create an endothermic reaction, which will add a phosphate back onto an ADP compound, and that will then equal ATP. So we're refueling or resynthesizing ATP here, and that is what a coupled reaction is. So why do we want to recreate ATP? What's the purpose of that? Well, if we want to have increase our stores, we would need to have more ATP. If we're just burning off and losing ATP and we're not resynthesizing it, we're not going to be able to create any more energy. Hello, welcome to the Newman Sixth Form. Hello, welcome to the Newman Sixth Form Year 11 into 12 taster lesson for physical education, BTEC Sport Level 3. please do go back and look at those slides that we've just been through, just to reaffirm your learning, just to cement it into your knowledge and your long-term memory if you can. Got a few activities that I'd like you to take part in. Firstly, you're going to read the keyword bank, which is on the next slide, and just start revising and learning those keywords. Go back through them. You've then got to fill in the blanks task that I'd like you to complete using the keyword bank that you've just learned. You're then going to cover your work up and write the 12 keywords out again that are in the word bank. And then the final thing I'm asking for you to do is to label the diagram. So I want you to label all of those enzymes, the compounds, every little bit that we went through. So you're going to label the diagram that we went through on the last slide. So that's the word bank for you. So some of the keywords: energy, coupled reaction, adenosine triphosphate or ATP, endothermic reaction, bonds, ATP, exothermic energy or exothermic reaction, phosphocreatine PC, anaerobic, creatine kinase, resynthesize. So there is your fill in the blanks task. This is where I'd like you to cover up your work and go through your keyword recall, see if you can say those 12 keywords and recall them without looking. And then finally, label the diagram. So labeling the grey compounds here and the enzymes. So what is this here? The enzymes that we learnt and all our differences. So just a small recap of what we've learned then, and just put it into a slightly different picture for you. So ATP is like a rechargeable battery effectively. The energy is released by converting it from ATP into ADP, so we're losing one of those phosphates to go and give us energy for our body. So it's in its uncharged form in ADP. By binding the phosphate back with ADP to resynthesize, recreate ATP, the battery is then charging up and it's ready for use on the intermediate and powerful muscle contractions. So we're looking at those short, powerful muscle contractions, throwing a shot put, a high jump, even a one slam dunk in basketball or a layup. Those short, high, powerful muscle contractions. However, your muscles only will have a small amount of ATP stored in them, okay? So to replenish ATP quickly, the body has to use a number of other systems as well. So we can't just rely on ATP. So back to that graph that we looked at a few slides ago, all of the three systems will work together. One will just be predominant. So it's an anaerobic system, so that means it doesn't require oxygen to produce the energy. We're only looking at ATP-PC, so it does it itself. We don't need oxygen to give us the energy. This is important for sports such as sprinting and shot put, where sudden powerful bursts of energy are required. This is because muscles can use ATP to produce energy. So like I said here, we don't need that oxygen. Just a bit of a plenary and a take-home thinking for you. So see if you can just answer these questions now off the top of your head. So what is ATP? What does it stand for? How do we produce energy from ATP? What happens to ATP to create ADP? What's the process? And what happens to ADP to create ATP? Again, what's the process? There should be a question mark on there. And just for a bit of further reading, if you wanted to go and look into the other two systems that we've not looked at today, so the lactic acid system and the aerobic system, we've looked today at our ATP stores and our ATP-PC system. So we've seen we've got roughly 2 seconds of ATP stored in our muscles, and we can extend that using the ATP-P system to roughly 10 seconds, giving us 12 to 13 seconds. But what do we do after that point? So after those 12 to 13 seconds, what do we start to do? Well, we then look at our lactic acid system in the shorter term and our aerobic system for the longer term. So good luck with that. I hope you've learnt something today, and I hope you have a better understanding of what the ATP-PC system is and what ATP actually is. If you have any questions at all about this lesson or any part of the course or the transition task that we've already set you, please do email me. My email is jemmett@cardinalnewmanschool.net. Once again, my name's Mr. Emmett, and good luck with everything.